So as we said, everything is in a class. Every file contains the one public class that has the same file name, and everything is case sensitive. So capital A, capital B not equal is not equal to capital A small b, not equal to small a capital B, not equal to capital small a small b. This is not this is not this is not that. And everything is included in a class, and the code blocks are included within opening and closing brackets. So that means that class code is written within an open and closing brackets. Every statement ends with a semicolon. Every statement. A program consists of code and data, and in the files there are comments that are not part of the code of the program, but very important. The comments are two types. Whenever you write two consecutive forward slashes, that means that from here to the end of the line, this is a comment that is not going to be read or noticed. Anything between slash asterisk and the next asterisk slash is a block comment. So we have a line comment and a block comment. Java is strictly typed. Now we are already about to start the new session. So take care, focus with me. And variables are declared, then assigned, then read. Okay. Last time we wrote some examples of variable declaration and assignment and reading, and to be used in the assignment and declaration and assignment of the next variable. If anybody has any problem with that, please raise your hand now before we go on. So far, so good. So far, so good.
Yeah.
Okay, that's great. I see that not everyone who was here last time is here this time. Asif was here. Taha Ismail, new one. Namir,
Yeah, I wasn't here for the last two sessions.
actually one session only.
Oh, okay.
Okay, do you have any problem until now, Taha?
Was it?
Do you have any problem until here?
No, I've seen the video.
Okay, that's fine. Okay, Namir and Rahim. I see two Asifs. Okay, anyway. So, nice. Let's go on.
Sorry, I had some connection problems.
Okay. Last time you were driving or out for some reason, I don't know why.
Yes.
So
And
you-
also I'm driving, but I'm listening in.
okay, but do you have any problems?
No, I'm good.
Okay. Now, variable declaration and initialization. So int a is a declaration only of a variable of the type integer. We'll talk about the type today. And we have a semicolon here that ends the statement. Let me make it a pen. We have a semicolon here. Okay. So semicolon ends the statement which declares variable a of type int. A equals 5 is an initialization only. We can make declaration initialization in the same statement. Here we made initialization with the value of a previous declared and initialized variable. So int b is a declaration of variable b, and initialized with a verb with the operator equals, and this is the value to be initialized that is read from this a. Float with another type, by and delta is declaration of two variables in the same line using the comma. This is declaration only. Now initialization of by, this time it can initialize with a literal, numerical literal 3.14. So here we initialize with int. Here Here by is initialized with a literal. Here A is initialized with a literal as well, but this integer is floating point. Here B is initialized with another variable. Long C and D, declaration of two variables using the comma operator of the type long. We'll talk about the types today. And here we initialize the C with a long value and initialize D with the output of operation coming from reading two values A and C. So now this is an operation now here. It's not A, not B, not A, not C. It's operation of summation of A plus C. The simple program we were going to, but I prefer to wait a little until I pass the next slide. Here is simple program. Everything is in a class, so we declare a class with a keyword class, then the class name. Here we call the class hello Java or hello world, whatever you would like, and opening bracket and closing bracket. As we said earlier, everything is in a class, and all code blocks are in brackets. Within the class, there is a main function, and this is always named public static void main in opening and closing parentheses string. This square bracket means array. We'll talk about it later when we talk about arrays, and we name it by convention. We can name it args. Then we have an opening bracket and a closing bracket. This is usually how it is. Memorize it now until we describe every single word by word. What does public mean? Static mean? What does void mean? What does main mean? What does string? What is string is? Okay, but what we care about here is that we write our code between these two brackets, between the opening bracket and closing bracket of the main function of the main class. So here we wrote system out of println, which is a standard way of writing something to the screen, writing a line to the screen in Java. We wrote hello, comma, Java, exclamation mark, and we end the line with semicolon. Let's go to IntelliJ and make this. I already have a function called hello world. Here we see public class main. This is the name of the class. Opening bracket and the close bracket is here. So we have only public class main with capital M. This is the name of the class. By convention, the class name starts with capital letter, written in a file called main.java. Here it is. Within the main class, the program starts from the main function with the small m. That teaches us that functions start with small letter. So instead of memorizing public static void main or string array args, we just write main. IntelliJ is an IDE that helps us writing code tremendously. So there are a lot of shortcuts that you can use to speed up your writing. So just write main and control space again, main control space. It creates main method declaration. Enter. Okay, public static void main string array args, opening bracket, closing bracket, and put the character inside. So all what we need is writing what? Through all the class, I will be asking questions like this, and I need you to interact and be responsive. So if I want to make a main function, what shall I write? Amir?
Main control space.
Thank you. Okay, and within here, within the main function body, I can write whatever I want. Let's say int. Let's say I want to print something to the string. I want to print something to the standard output as I just mentioned. Just write s out. I have s out, s out t, s out, and s out m, s out b, s out v. Just write s out. Control space. Now enter. Oh, sorry, this out. Enter. So assist out println and opening bracket, closing opening parentheses, closing parentheses, semicolon, and it put the caret in between them, and it also recommended something to write. Let's escape this. Here I can write whatever I want. I can write 5. This out 6666. This out Wait, Java. Okay. Let's run this and see what will happen. We click on the run main.java. Let's click. Now run. Yes. Now building. Building is done usually once and is done whenever there is a change. So only you will wait a lot only for the first time because it does pre-compilation operations, compilation operation, post-compilation operation. But then any run will be a matter of milliseconds. It's building the whole project. Please bear with me. As we are waiting for the build, this is why IDEs are important. IDE stands for Integrated Development Environment, like IntelliJ. So instead of writing all compilation and installation and running applications in command line, you just click one button and that's it. And you can go save a cup of Java until your application runs and finishes. We can make use of the time. Continue the presentation until this compilation either finish or fail. There's a simple program which should be running soon. Java has pre reserved keywords. 1, 2, 3, okay. Around 40 words, 40 keywords that you cannot use otherwise because they have specific meaning. Here are the words in alphabetical order: abstract, assert, boolean, break, byte. You don't need to know any of them. To know them, we will use most of them later. But I just want to say that they have meanings, like the word int, int and I, meaning that this is a declaration of an integer variable. Class, declaration of a class. If is a condition statement. Okay. Import, which we mentioned in the first lecture, means that we need to import the class definition of something from another package here. Okay, etc. etc. Just what I'm saying here is that the Java keywords are keywords that are not used except for specific meaning. You cannot use them as variable name or class name or method name or whatever. So you cannot say you cannot define a class called class with all letters small, or a class or a variable called car, or a function called new. You cannot do that. But you can say, you can make something like new robot. This is fine. Okay. The program entry point is a public static void main, and we can create a function main using the shortcut main. Okay. What is a computer? Can anybody define? Tell me what is a computer? The computer is. Taha?
It can store information.
No. The answer is much simpler. What is a computer? You said something that stores information. No, this is called storage. What is a computer? very
Something,
simple.
something that processes data.
The answer is much simpler. The thing which processes data is called a processor. What is a computer? Simple, very simple question, by the way. Don't go far with your mind. The thing which stores is called storage. The thing which process is called a processor. What is a computer? Something which computes. As simple and straightforward as this. Right? Hello?
Yeah. Yeah.
The computer is something which computes. Do you see my screen?
Yes.
Yes.
What do you see?
Java
Uh,
operators.
Okay, so the right screen. Okay. So the computer is something which computes. And in our case here, we refer to electronic device that computes, does some computation on data, processing it, blah, 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 blah. Okay, that's fine. To do some computation, you need some operators. There are arithmetic operators like plus, minus, equal, no, plus, minus, multiplication, division, some other operators, etc. And some assignment, comparison. And there are some operators that are only used in computer science. So let's take them one by one. In mathematics, we already use some of those operators, but not all of them actually. So you must be familiar with some of them. We have addition operator. We all know this. Subtraction operator. We all know this. Multiplication and division. All of us know that. Right?
Yes.
Yes.
Okay. So I don't need to explain what x plus y, x minus y, x asterisk y, or x slash y mean. But let me talk about the three new operators. The first one is modulus. If I divide 3 apples by 3 friends, what is the division output?
1.
Okay. If I have 4 apples and I don't have a knife and I want to distribute it to give apples to my friends, to the same 3 friends, what is the output of the division?
4/3.
Yes, what is the output? If I don't have a knife, everyone will take 1 and the fourth apple will remain in my hand. Right?
Yes.
So this is the division remainder. If I have 5 apples and I don't have a knife or I don't want to cut any apple, everyone will take 1 apple and 2 will be the remainder of the division. If I have 6 apples, everyone will take 2 apples and the remainder will be?
No remainder.
Thank you. Mathematics, the remainder will be?
0.
Thank you. Nice. So this value is retrieved using this operator, modulus operator. This is the same symbol which we use for which indicates percent. It's used an operator called modulus. It returns a division remainder. So if I write like here, if I write Right, 5 modulus 2. The output is 2. Okay?
Okay.
Fine. Now let's go back to this operator. This is a division operator, and it works in 2 modes. First mode, which we all know. Actually, second mode. Second mode, which we all know. This is the decimal division. 5, 5.0 over 2 equals, this is the one which we all know, equals
1.2.
1.26, 1.6666, right? Second mode is when we have 5 without this dot 0 over 2. This produces the integer value, which is 1 only. Dividing division where any of the operands is a decimal value, like 5.0 or 2.0, even dot only is enough. 2 dot is enough. Let me highlight. When any either or both of the operands is a decimal, will produce a decimal. Okay? But when both operands are integers, 5 as an integer and 2 as integer, the result will be integer, and the remainder can be retrieved using the modulus operator. Okay?
Okay.
So far so good?
Yes.
Okay. What is the direct application of this modulus operand operator? I have a simple application, and you all will relate in robotics. If I have a robot that is directed exactly towards the target, let's say the target is a screen. Okay, so the deviation angle is how much from the target? Asaf? Asaf?
Yes, Assalamualaikum.
If the robot is directed to the target, then the deviation angle is how much?
0 degrees.
Repeat, please.
Sorry, are you asking the angle? It's 0 degrees going straight, is it?
If my robot is directed to the target, then the deviation angle from the target is how much?
0.
Thank you. Now, if the robot deviates 10 degrees to the left, the deviation angle is 10.
Yeah.
If it turns 10 more degrees, the deviation is 20. 10 more degrees, 30. Right? If it keeps deviating, it will be 90. More will be 180. More will be 270. Right? Right?
Yes.
More will be 350. which is equal to minus 20. Okay? Sorry, minus 10, sorry. Are you following?
Yes.
Okay, if we deviate, if we turn more 10 more degrees, so the deviation will be how much?
Back to 0.
Exactly. The deviation will be 360, which is effectively equal to 0. If you keep deviating 10 more, it will be 370, which is effectively equal to 10 only. Okay? After a complete turn, 10 degrees after, 10 degrees after one complete exact turn. 10 degrees only. So if I tell you that the deviation angle between the robot and the target is 3,600, it means that the robot has turned 10 complete turns and the deviation is exactly 0. This is a simple application of, and if I tell you that the deviation angle is 3,601, it means that the robot have rotated 10 complete rotations and plus 1 degree. So the 3,600 is equal to, and 1 is equal to only 1. How we reach it? We got that by calculating the modulus of the deviation d prime equals d modulus three 60. Everybody's following? So 360 modulus 360 is 0. 361 modulus 360 is only 1. So far so good?
Yes.
Okay. That teaches us what modulus is. The next two increment and decrement operators, the operators, we will talk about them later. But simply they mean increment the value of a variable by 1 or decrement the value of the variable by 1. So a variable has a contains the value 60. It will be 61 if we call the plus plus operator, or 59 if we call the minus minus operator. We can do the same effect of, you can reach the same effect of calling minus minus or plus plus by doing plus 1 or minus 1. However, this operator, and of course that operator, these are much faster and efficient, but later we'll talk about why and how when we see the assembly of this operator. Okay, that was the first set of operators. Now, in my courses, usually I tend to give you the holistic view. So when we do something, we study this concept in deep details until you understand it heavily, and then we switch and apply directly and lightly on the rest of concepts. So you know something in deep, and you see the whole picture, so you can apply it on other domains. Okay, so this was the This was the arithmetic operators. Let's go to next operators, which is the assignment operators. We all know that as assignment is in mathematics from primary school mathematics. We know that this is called the assignment operator. X equals 5. As simple as this. That sets the value of the variable x to 5. Any problem with that? Any problem with that? Hello?
No.
Okay. All the remaining assignment operators are a short way of writing an operation that ends in assignment. So if I want to increment the value of x by 3, if I want to add, I don't say increment. If I want to add 3 to the variable x, I can say x equals x plus 3. This means, mathematically, this is not a mathematical formula, by the way, because x can never be in mathematics equal to x plus 3. This is a computer science formula, not a mathematics formula. It means new x equals current x plus 3. Is this clear? Let's say that we have a car or a robot moving at speed x. There is speed in x direction, speed in y direction. Or let's say speed, location. I want to move the robot from x equal 200 to x equals 203. So I move it by 3 steps, by 3 centimeters. I will simply add 3 to the current x. How can I write that in a computer science? I want to set x of 3 to the current value of x plus 3. Written as x equals x plus 3. The right hand side is evaluated is what? Is what? رحيم اسمك رحيم. The right hand side is what? رحيم رحيم. Okay, Namir.
Yes.
The right hand side is what? Evaluated is what?
Evaluated.
Thank you. Then the value, the result of evaluation is set to the left side. This is the right hand side, this is the left hand side. The right hand side is evaluated, then the result is assigned to the left hand side. Okay?
Okay.
Because the concept of evaluation and reassignment occurs frequently in computer science, they created the set of assignment operators. So if you want to do plus then assignment, you can write it this way or write it this way. Plus equals. So when you say x plus equals 3, that is a shorthand of writing x equals x plus 3. Actually, it's not shorthand. If you want to hear the exact answer, the exact details, this way is not only shorter in writing, but it's faster in application. For the same reason why we say that minus minus and the plus plus are faster. We'll talk about later, but keep in mind now, for now, is that plus equal is as effective as equals x equals x plus 3. The same for minus. This plus equal, this minus equal, this is multiply equal, this is divide equal, this is modulus equal, it's called the rest later. So x equals x minus 3. The right side is evaluated, x minus 3. So if it's maybe 1000, it will become 997, and then assigned to x. The same effect we can reach by writing only x minus equal 3. X times equal 3 means I multiply the value of x by 3 and return it back to x, assign it back to x. Who will explain this operator?
X equals x divided by 3.
Right. Okay, who is going to explain this? X equals x, the remainder of the division x by 3. Fine? Fine?
Yes.
Yes.
Okay, now the best student today will tell us an application from what we said earlier of this statement. Not equal, not exactly 3. The division equal. Give me a real world application of modulus equal operator. Muhammad, don't answer. Not 3, not necessarily 3. Some any other value similar. I just want to see what something here. Give me a direct application of this statement. X modulus equals something. And I said, I gave you a clue earlier today. Shall I say and call myself the best student?
It's so if you can, in the real world, it's so if you can figure out what you have left after you divide something.
Yes, give me a real world application of, if you want to.
Like a scenario?
Yes.
If you have, I don't know, 5 gifts for someone, 5 gifts, and you have 4 friends, how many gifts do you have left?
Okay, that's right. That's right. Anybody else can give me another example of real world application of this operator from what I said today. If not, Taha will be the best student for today. Hmm. Okay, let me say it and be the best student for today. When I want to limit the degrees of whatever measurement to the range from 0 to 3060. Actually, it's 3059. Do you all agree?
Yes.
Not A. This is 300. So, okay, so I am the best student for today. Okay? Now you know the assignment operator, you know the complex, these four complex operators, plus minus, plus equals, minus equal, multiply equal, divide equal, and modulus equal. Okay?
Okay.
These remaining 1, 2, 3, 4, 5, these remaining 5, we'll discuss them when we talk about bitwise operators. These are related to bits. But I put them here so that you see the full picture. Later you will grab the idea in a second. Okay. Then comparison. Do you know any inequalities?
Yes.
Yes.
Right. We use a similar concept if you want to calculate, if you want to evaluate something, some value, whether it's equal to some other value, or greater than it, or less, or greater than or equal, or less than or equal, or simply not equal other value. Uh, they are used for comparison. For comparison. If I want to know the distance between my robot and the two targets to decide to which one should I go first. I have two distances. The comparison between two values will be either they are equal or not equal. If they're not equal, then this is greater than this, or this greater than this. So how can I take a decision? The comparison is the comparison operators are 6 operators. Equals 2. And as we all know, equals 2 is written as this format in mathematics. But this is the use for assignment operator. The assignment operator. So they invented another format, another operator that is equals. Because if we use equals, a single equals, it means an assignment. Let's try that. Okay. Now int a equals, let's say equals 10 directly. D equals for degree. D equals how much? 10. Print B will print. Okay. Let's run this. Okay, so this is 10. Let's add some lines. D plus equals 40. How much will it be?
50.
Right. Control. فين اللي انت بترن بايه؟ شيفت فانكشن.
انا بدوس كده وخلاص هو بيبند ده كل ده
24
صح؟
في اوبريشنز كده بتحصل. Okay, 10 then became 15. Okay. Now, let's use other format. D equals D plus 300. How much will it be?
على فكرة انت المفروض
350.
350. عايز ايه؟
انت المفروض تستخدم
لا، عايز ايه؟
تستخدم ماجيشن
المرة الجاية حاسب. حاسب دلوقتي خلاص. It's out. D. Became 350. Okay. D plus equals 20. It's out. Labyrinth length D. How much will it be?
370.
Right. Maybe I can do it in a simpler way, but anyway. Okay, nice. Now it's time for the next operation. D modulus equal 360. How much will D be?
10.
Thank you. Okay.
Right.
Let's make it a little. Let's play a little. So D equals 10.
استخدم زي شيل
استنى عايز اعمل. Let's do it little playing, just playing. Now we get the idea, but I want to try different, more different operators. So instead of plus equals, let's say times equal 40 become 400, and then
so include
equals minus
100
50 becomes 350. This should be this should give the same the similar
لا
similar
ايوه
10. Yeah, 10 times 40 becomes 400 minus 50 becomes 350 plus 20 370 minus 360 is 10. Okay.
Okay.
So far so good.
Yeah.
Okay, that's great. Let's continue the presentation. What was the presentation? Stop sharing. presentation shift في 5. Okay. Comparison. need to شايفين حاجة؟ because I didn't share yet. I need to share. Share screen. Okay, comparison operators. Let's play with the comparison operators. We have equals equals, which means equals to. This sign before anything means not. In computer science jargon, C++ jargon. Okay, so it is not equal. We all know this, greater than. We all know this, less than. This is how we write greater than or equals. And this is how we write less than or equals. Okay?
Okay.
Nice. The comparison operators produce a value that is either one of two. True or false. True or what? Or false. The value, again, the value is either true or false. So if I say 5 equals 7, 5 equals 7, is this statement, is this expression true or false?
False.
Fine. If I write 3 not equals 7, is this true or false?
True.
If I write 3 less than or equals 7,
It's true.
3 greater than or equal 7,
False.
3 less than 7.
True.
Did you get it?
Yes.
Okay. Let's try that very quickly. Muhammad's screen. I want to try the J shell. Should be faster. وده ازاي؟ وده تحت ازاي؟ شكرا. The J shell should be faster. Tools.
No.
Chemical biology. A int A equals 6. Int B equals 7. A equals B. Okay, okay. A greater than B. A less than B. A greater than or equal B. A less than or equal B. A not equal B.
Not equal.
And
Equal.
I say
Not A ليس B فوق.
مش فارقة. Let's see them one by one. This is too much. Let me clear it all. And
لا. وتدوس هنا بس.
بس أنا هعمل إيه؟ Okay. So A equals B is false. Greater than B is false. Less than B is true. Greater than or equals false. Less than or equals B is true. Not equals B is true. So far so good?
Yes.
Yes.
Okay, that's great. After the comparison operators, we have logical operators. Logical operators are used to combine operators that are either true, values that are either true or false. So if I want to say uh, if the degree tomorrow is above 70 degrees Fahrenheit and I am free, let's go out. Okay? The degree, the temperature tomorrow greater than 70 is a logical expression that is either true or false. I am free is another, I will be free is another expression, logical expression that either true or false. Are you following? When we combine logical expressions, we combine them using logical operators. Let's give another example in robotics. When the deviation angle, if I want to go to the target with tolerance, so I can tolerate plus or minus maybe 5 degrees. If I'm going directly to the to the target, that means my deviation is 0. If I deviate this way, it's minus. If I deviate this way, it's plus. Are you following?
Yes.
Okay, so if I want to give plus or minus 5 degrees tolerance, then the deviation should be something between minus 5 and plus 5. This can be wrote in this form. D greater than or equals minus 5 and which we'll scrap later. D is less than, sorry, what can I undo? Less than or equals 5. This is a value. Let's write it in highlight here. Where is the mouse? You see the mouse? writer. Okay. This is a value. This is a value. This is a comparison operator. This becomes a logical operator, a logical expression. This is a value, literal. This is a value in a variable. This is a comparison operator. This becomes a logical operator. So if the degree of the deviation now is plus 3, this expression is true, this expression is true. Suppose the deviation now is plus 6. So 6 is greater than or equal to minus 5? Yes, that's true. 6 is smaller than or equal to 5? No, that's not true. So this false. Are you following?
Yes.
Okay. We have two ways of linking logical operators. They are the AND, the logical AND, and the logical OR. Because they link logical operators. 6 is true here and false here. True here and false here. 3 is true. Let me control then eraser. Then what color? Red, not green. 6 is true to the left, false to the right. 3 is true to the left, true to the right. Minus 2 is true to the left, true to the right. Minus 7 is false to the left, true to the right. What does that mean? Minus 7 minus 7 it is less than or equal to 5, correct?
Yes.
Yeah.
That's true. So it's true. But it's not greater than or equal to minus 5. Agree?
Yeah.
Okay. And you can follow the 4 of them. Now there are mainly 2 ways of combining logical operators. There are more, but let's talk about these 2 main: the AND and the OR. AND operator joins logical operator, joins 2 logical expressions, and produces 1 logical expression that is either true or false. It will be true only if the first and the second are true. Otherwise, it's false. If I am free and the temperature is above 70, we can go out. If the temperature is above 70, but I am not free, we cannot go out. If I am already, yes, if I'm free, but temperature is below 30, we cannot go out. We will go out only in the case of the first and the second operand are true. Is it clear now?
Yes.
Okay. Now for the or. And listen to this. This is called or. Actually, here it means any of. I want to leave the United States. I want to leave my current work in the university and go to another university in another country. So if the other country is good or the other university pays well, I will go. If the other university pays well, I can tolerate the bad environment and go. If the environment is good, the country is good, but the university does not pay well, I can tolerate the bad poor payment as long as country is good and I can go. Okay. Now, what if the country is good and the other university pays well? Shall I go or not?
You will go.
Okay. So what is the only case where I decide I'm not going? When the country is bad and the offer does not pay well. Right? Right?
Yes.
So the OR operator joins two logical expressions into one logical expression that is either false if both of them are false, true otherwise. The AND logical operator joins two logical expressions into one logical expression that is either true in case both of them, the first and the second, are true, uh, false otherwise. Is it understood?
Yes.
Yes.
Okay. There is a third operator which is not mentioned here. That is called XOR, which means exclusively OR. This is we are not going to touch it now today, but it means if the first but not the second, or the second but not the first, the result will be true. But we're not touching it today. Now there is or, but there is exclusive or. So don't fall into thinking or means either. Or is simply the opposite of and. Or does not mean either. Anyway, this third operator is called logical not. It simply negates or reverses the input. If I say the truth, it will be true. It become false. If false, will become true. We still have 10 minutes until next lecture. Giovanni's lecture. Variable types is going to be um, um, a complete topic to talk about next time, inshallah. Can we have a lecture in the middle of the weekday?
I'm not sure. You might have to talk to some of the coaches.
We don't know.
Okay, we'll discuss it later. Let's stop here. We will be talking next time from variable and data types. Okay. Anybody have any questions?
No.
No.
Okay, fine. See you inshallah next week, unless I declare lecture maybe Tuesday or Wednesday. Let's see that. Salam alaikum.
Alaikum salam.
Control space.